Let us start with the fourth question of exercise 7b. It's given, if x plus 5 is the mean proportion between x plus 2 and x plus 9, find the value of x. So, three quantities are there. Three quantities means it is in continued proportion. So, value of A, B and C is given to us. A is x plus 2 and B is mean proportion. I have already explained this concept. So, this x plus 5 is mean proportion. So, that is why it is B, and C is x plus 9, the third proportion. Now, these are the three quantities. They are in continued proportion because only three quantities are there. So, we have formula B square is equals to AC. I have already explained the concept of continued proportion, and if you haven't seen the introductory video, I have shared in the description. You can check out that video, then you can proceed with this. So, B square is equals to AC. We will just substitute the values of A, B and C in this formula. So, B is x plus 5 B square. So, its whole square I will do B square, x plus 5 whole square. A is x plus 2. AC means A and C, they are getting multiplied. So, A into C is x plus 9. Whole square, we have identity. So, that identity we can use A plus B whole square. A plus B whole square, it is equals to A square plus B square plus 2AB, 2 into A into B. So, in smaller classes we have learnt this identity. So, this we will use here because x is our A and B is 5. So, I will write x is A and B is 5. So, A square means x square plus B square. B square means 5 square plus 2 into A into B. So, 2 into x into 5. Just identity, this one I have expanded accordingly. Now, these two brackets are there. So, two brackets, like the way I have told you, same way we will multiply first term of first bracket, then we will write the full second bracket, which is x plus 9 in second term along with the sign and full bracket. So, this we can write x square. 5 square means 5 into 5, 5 into 5 is 25 plus 2 into 5, 10, x as it is equals to this. We will multiply whenever bracket is there and a number is written outside. So, the number which is written outside, this has to be multiplied by both the numbers. So, x into x square, like I have already told, two numbers when they are multiplied with itself, same number, it will become square, like A into A square, like if number 2 into 2, that is 2 square. So, x into x square plus 9 into x 9x plus 2 into x 2x, 2 into 9 18, because this 2 is written outside. So, it has to be multiplied by both the numbers inside the bracket. Now, we can solve x square plus 25 plus 10x is equals to, see these two are like terms, 9x plus 2x, with both the numbers 9 and 2 x is written. So, that means these are same terms. So, same terms can be added or subtracted. 9 plus 2 is 11, x as it is plus 18. Now, we will shift all these terms to this side. X square plus 25 plus 10x as it is. This plus x square, when we shift it to other side, it will be changed to minus x square. Plus changes to minus on changing the side. Again, this plus 11x, it will be changed to minus 11x. Plus 18 also, it will be changed to minus 18 is equals to 0. Because now on this side nothing is there. If nothing is there, so we can write 0. Now, all the like terms we can add or subtract. So, first we have to find out which are the like terms. X square and x square, these are like terms. Then 10x and 11x, these two are like terms. Then 25 and 18. So the similar numbers, x square minus x square, x square minus x square, it will be 0. So we can directly cancel same number. When we subtract from itself, it will give us 0 as answer. 10x minus 11x, 10x minus 11. So 10 minus 11, 10 minus 11, minus plus minus, but the sign which is with a bigger number. So with bigger number, minus sign is there. So 11 minus 10 is 1, but with bigger number minus sign is there. So minus 1, x as it is we have to write. So this is done. 25 minus 18, 25 minus 18 we can just do the subtraction. So 15 minus 8 is 7, then so 7 plus 7 we can write is equals to 0. Now x we only have to find, 1x means x only, so x we have to find, that means this 7 we can shift to other side. So minus x is equals to plus 7, when we shift to other side it will be changed to minus 7. So 0 minus 7 we can write, or 0 minus 7 will be equals to minus 7 only. Minus and minus sign will get cancelled, so x is equals to 7. The value of x is 7. In the fifth question, it's given to us, if x square, 4 and 9 are in continued proportion, find x. So this question is very similar to the previous one. See, you can just try along with me and see whether you are getting the same answer or not. Continued proportion, the formula I gave you, b square is equals to ac, where b is the mean proportion, a is the first proportion and c is the third proportion. So all the values are given to us. A is equals to x square, b is equals to 4 and c is equals to 9. So accordingly we will substitute the values of a, b and c in this formula and we'll find the value of x. So b square is equals to ac, b is 4. In place of b we can write 4 whole square. A is x square into c is 9. So 4 square means 4 into 4, 4 into 4, x square as it is into 9. 9 also what we can do here, it is getting multiplied by x. See, what we have to find, we have to find x. So what we can do, we have to keep x on this side and remaining all the things we have to shift to other side. So step by step, all together we cannot shift everything. So first this 9 we will shift. This 9 is getting multiplied by x square. So this 9 when we shift it to other side, it will get divided. So 9. 9 also we can write it as 3 into 3, because we know 9 is what? 3 into 3. So in that form if we write, it won't make any difference here. 4 into 4 and 3 into 3, 4 into 4. We can keep it this way, or we can just write 4 square by 3 square. 4 is getting, it was already in square form, so again we can write it in this form, 4 square by 3 square. Why I have written this way? Because here I have x square. That is why I wrote it in this way. So now this with 4 also square is there, with 3 also square is there. So what we can do, this square instead of writing 2 times, I can just write it as 1 time. In exponents we have already learnt in class, smaller classes we have learnt the rules of exponent. If the same power is there with both the numbers, then we can just put this power with this bracket, because bracket means whole power. This is with 4 also and it is with 3 also. So one single time I wrote. Now 4 by 3 is whole square, it is equals to x square. This square and this square, it will get cancelled, same powers will get cancelled. So we will get x is equals to 4 by 3. This way we can solve it. In question number 6, it's given, what least number must be added to each of the numbers 6, 15, 20 and 43 to make them proportional. So which number can be added to make them proportional? See, let us assume that that number is x. Let the number x is added to each to make them proportional. So that means if we add 6 to each of the numbers, these 4 numbers, like 6 plus x, then 15 plus x, 20 plus x and 43 plus x, the numbers will become proportional. Proportional means, like I can write it in this way, 6 plus x is to 15 plus x, they will be proportional. This is a sign of proportionality. We have already learnt 20 plus x is to 43 plus x. Proportional means the ratio of first two numbers, it will be equal to the ratio of last two numbers. So this I can write it in fraction form. This 2 dots means this sign. So 6 plus x by 15 plus x, this sign, it means equals to 20 plus x by 43 plus x. Or what we can do, we know when the 4 numbers, when the 4 quantities, they are proportional to each other. So direct formula also, if you want, you can apply. So here we will just not do this one. See, these middle ones, these two, these are means, and last outer ones, these are extremes. So I have given you one formula, that product of extremes, it's equal to product of means. So this directly we can apply the formula. These two are means, middle ones, and the outer ones are extremes. So I will write it in this way. Extremes are 6 plus x and 43 plus x. Product of this, it is equal to product of this, 15 plus x into 20 plus x. Now we can just multiply, two brackets are there, same way like I have told you, first term of first bracket, then entire second bracket we can write, then second term of first bracket along with the sign we have to take, then entire second bracket is equals to, same thing here also we have to do, first term of first bracket, entire second bracket, then second term along with the sign, entire second bracket. Now we can multiply. See, this 6 will get multiplied by both, with 43 also, with x also. So 6 into 43 we can multiply, 43 into 6, 6 into 3, 18, 24 plus 1, 25. So 258 plus 6 into x is 6x, 43 into x is 43x, x into x, x when it's getting multiplied by itself 2 times, so that means x square, 15 into 20 it is 15 into 2 30, 1 0, so 300 plus 15 into x 15x, 20 into x 20x, x into x, x square. Now we can shift all the terms to one side and then we can add like terms. So 258 plus 6x plus 43x plus x square, all the terms are already on this side, so no need to make any change with the signs. Now all these terms we can bring to this side. So plus 300 on changing the side will be changed to minus 300. Plus 15x it will be changed to minus 15x. Plus 20 it will be changed to minus 20, or you can also add these two and collect in a single way you can bring. This way also you will get the same answer, so no worries here. So then plus x square it will be changed to minus x square. On other side nothing is there, so that means 0 we can write. Now all the like terms. this 258 and 300, these two are like. So first we will solve this. 258 minus 300. See, 258 minus 300, for plus minus plus is minus, so that means 300 minus 258 we have to do. It's 42, but the sign with which is with the greater number. So greater number is 300, with greater number minus sign is there, so minus 42. Now this 6x and 43, these are like terms, because with both the terms x is there. So 6 plus 43, 49, and these two are also like. 49 minus 15, or you can just add these two. Here also we can add 15 plus 20, it is 35. So altogether I can write it as 35. So minus 35, because it will be plus 35. When I change the side, it will be changed to minus 35. So 49, this is 49, 6x plus 43x, 49 minus 35. So 14 minus 14, x as it is we have to write. Now this x square and this x square, plus x square and minus x square, both will get cancelled, because if we subtract same number from itself, we will get 0 as our answer. Now this 14, with this x we have to find, because x we are adding in each of this to make them proportional. So x we have to find. So what we can do, we can keep the term with x this side, other term will shift to other side. So minus 42, if we shift it to other side, it will be changed to plus 42. Minus and here it will be plus 14, because 43 is 43 plus 14, this is 49 plus 49x and minus 35. So plus 14, by mistake I just wrote minus sign, so it will be positive 14x. Now this 14 also we will shift to other side, it is getting multiplied by x. So when I change the side, it will be changed to division, because multiplication on changing the side will be changed to division. So 14 into 3 is 42. So that means 3 must be added to each of the terms, each of these numbers, to make them proportional. In 7th question, it's given, if a, b and c are in continued proportion, show that a square plus b square by b into a plus c is equals to b into a plus c by b square plus a square. See, in this type of questions, it's mentioned show that. So we have to show or prove that left hand side is equal to right hand side. So for that we just have to use the given things. See, whatever is given to us, we'll make use of all the given things to prove these two sides equal to each other. So let's start. So first we will write all the given things. So first, this thing is given to us, a, b, c are in continued proportion. So continued proportion I have already discussed, that in continued proportion a is to b, it is proportional to b is to c, because only 3 quantities are there. So ratio of first and mean proportion, it is equal to the ratio of mean proportion and the third proportional. So I can write as a by b, it is equals to b by c. So that means this is given to us. And one other thing, because whatever the things are there in mean proportion, continued proportion, that means all the things are given to us. So one is this thing and the other one is this, b square is equals to ac. If a, b, c are in continued proportion, then b square is equals to ac. From here itself we are getting, if we do cross multiplication, we will get b square is equals to ac. So this is also, these two things are given to us. So wherever we can make use, we have to use this to prove these two sides equal. So I'll start from left hand side. It's a square plus b square upon b into a plus c. So a square as it is plus b square. See, b square, since ABC are in continued proportion, then b square is equals to AC. So here we will substitute the value of b square as AC. B into a plus c. See, we have just substituted the value of b square as AC. Now a square also we can write it as, see, a square we know it is a into a, because same numbers when they multiply they will become square, like 2 into 2 is 2 square, 3 into 3 is 3 square. So when we multiply one number 2 times with itself, I can say, so then it will become square. So I have just written in expanded form. So a square is a into a. So why I have written in this way? So that I can show you that a is present in both of the terms, a square also and in AC also. If directly you want, directly you can take it out common, because we have to take common, it's present in both. So this a, I will take it out, and remaining terms I will write as it is, a, because one a I have taken out, so other one a is there, plus here a we have written outside, so we have only c now, a plus c, by b this a plus c. Now a plus c and a plus c, it will get cancelled, same terms they will get cancelled, so we are left with a by b. Now let's solve right hand side. So right hand side it's given b into a plus c by b square plus c square. So b into a plus c, as it is we will write b square. Again we will substitute the value of b square as AC plus c square. See why I have taken it out, because we know we can, if it is in this form, we cannot take out anything common and we cannot solve it further also. So whatever given to us, b square is AC, it's given to us, so we will make use of this to solve. C square means c into c, so I will write it in this way. Now here I can take common c is there in both. So b into a plus c, as it is I will write, c I will take it out, a plus c. A plus c and a plus c, it's same term, so we can cancel, b by a. Now b by a, see I have written b by it is c, b by c. B by c, it is equal to a by b. So I can write it equal to a by b, because it is already given to us. Now on solving left hand side also we got a by b, and on solving right hand side also we got a by b. So we can write hence proved. In second part of 7th question, it's given if a, b, c are in continued proportion and a into b minus c is equals to 2b, then prove that a minus c it's equals to 2 into a plus b by a. Same way we have to use, first of all we have to make use of the given things to prove this thing. So I will write given things first. So a, b, c are in continued proportion, so that means a by b it is equals to b by c, which implies b square is equals to AC. This thing is given to us, then this is also given to us, a into b minus c is equals to 2b. See, this thing first we will solve, so that we can use it while proving these two things. So this, I am just solving the given thing first, so that we can use in proving this. I haven't started solving right hand side and left hand side, I am just solving this given thing further. Now A into B minus C. So let's multiply brackets. So when a number is written outside the bracket, we have to multiply it with all the terms inside the bracket. So A into B is AB minus A into C is AC is equals to 2B. So why we are doing this? Because this is given to us that B square is equals to AC. So somehow we have to make use of it. Now AC, AB as it is, we have to write AC. AC is equals to B square, because A, B, C, they are in continued proportion. So B square I will write in place of AC, just substituting the value of AC as B square. It is equals to 2B. Now AB minus B square, same way B square means B into B is equals to 2B. I have just written in the expanded form. B square is B into B. So why I have written? So that you can see that B is common in both. Now I will take the common term out and remaining terms I will write as it is. Here A minus B is equals to 2B. Now this B, it is getting multiplied with A minus B. So we will shift it to this side. The other reason is that here also I have term which has B. So like terms let's write together. So it is getting multiplied this side. If I change its side, it will get divided. So multiplication on changing the side, it gets divided. It will change to division. So B and B will get cancelled. So A minus B is equals to 2. This is, I can say again, because I solved the given part and then I got A minus B equals to 2. So this result also we can use while proving. So let's start from left hand side. So left hand side is A minus C. A minus C. So what we can do here, we can multiply and divide this A minus C by A. See, while proving, whatever we can do, we have to do that so that we can reach our goal. Goal here is to prove these things. So I can do anything, but it should be correct. So it should be acceptable, I can say. So multiplying and dividing this A minus C with same term. See, it won't make any difference because this will get cancelled and this will get cancelled. So it is still the same thing, A minus C. So that is why I have just multiplied and divided A minus C by A. Because A minus C individually we cannot solve. Now this A is written outside the bracket, so it has to be multiplied by both the terms. A into A square, minus sign as it is, A into C, AC by A. Now A square minus AC is equals to B square. It is given to us. So again we will substitute the value of AC as B square by A. Now we have used one identity, A square minus B square. In previous questions also we used A square minus B square. It is equals to A plus B into A minus B by A as it is we will write. See, I have just expanded it. A square minus B square, it is equals to A plus B into A minus B. So I have just written the expanded form of this. Now from the given part, when I solve the given part, I got the value of A minus B is equals to 2. So A plus B as it is we can write, this is multiplied by A minus B. A minus B is equals to 2. So into 2 we can write by A. So multiplication I can write just it here, because if we multiply two numbers like 1 into 5 is also 5 and 5 into 1 is also 5. So it's commutative, multiplication is commutative, so we can interchange the positions, same number we will get. So that is why 2 instead of writing here I have just written here. So 2 into A plus B by A. Now if you see your right hand side also, right hand side is also 2 into A plus B by A. So after solving left hand side, I got 2 into A plus B by A, which is equals to right hand side. So right hand side now no need to prove anything, it's already equal, hence proved. In third part of 7th question, it's given if A by B is equals to C by D, show that this two terms, that A cube C plus AC cube by B cube D plus BD cube, it is equals to A plus C whole power 4 and B plus D whole power 4. So this we have to prove. Now whenever this thing is given to us, what we can do, because these are already equal, so we can just write A by B, it is equals to C by D, it is equals to K. K is any number we have just assumed, because they are already equal, so that means if they are equal to each other, they will be equal to one same term, so that I have assumed as K. So that means A by B is equals to K, because the sign of equality is there. So if these two are equal to each other, and then this will be equal to this also and will be equal to this also. So A by B it is equals to K, so which means A is equals to B. I will just shift to other side. So B, if I shift to other side, it will become B into K, because B is getting divided this side, so if I change the side, it will get multiplied. So A is equals to BK. Now if I C by D, it is also equals to K if separately I write. So D, if I shift to other side, I will get C is equals to DK, because D is this side, it is getting divided, so if I change the side, it will be changed to multiplication. So D into K, DK directly we can write, if here dot we can write, if you don't write also, it means two alphabets written together means they are getting multiplied. Now let's start. So these two things are, we can use these two things while solving the question, while solving the left hand side and right hand side. So I'll start from left hand side. So wherever you see A, just substitute value of A as BK, and wherever you see C, substitute its value as DK. So I will write it down, A cube C plus AC cube upon B cube D plus BD cube. Just try to do this question along with me, so that you can see, you yourself can experience how to solve it. So A, I have told you, wherever you see, first we can make it simple, because see here AC is common, so AC is common, so AC we can write it outside, because here A cube means A into A into A, C cube means C into C into C. So AC is there in both, so I will just take it out. Now one A I have taken out, so remaining two A's are still there. Two A's means A square. C I have taken out, plus AC, again one C and one A I have taken out. So here if one C I have taken out, still two C's are there. So 2C means C square. Then B cube D, here also if you want, because BD, same way BD is there in both, so BD we can take it out. So here B cube is there, B cube means B into B into B, like same way B into B into B. So B1 if I take it out along with D, so I am left with only two B's, that means B square plus again BD. BD I have taken it out, BD. So three D's are there, D into D into D. One D I took out, remaining two D's I have to write as it is. See, if you multiply it with the bracket terms, you can see you will get the same terms. Now let's substitute. A, I told you it is equals to BK, so in place of A, let's write BK or B into K, and in place of C, C is equals to DK. So all the alphabets written together means they are getting multiplied. So A square, A is equals to BK, so that means BK square. C is equals to DK, so that means DK square, over BD. into b square plus d square. See, here we will not make any change because we have already converted AC in the form of b and d, so that similar terms we can get and we can do any cancellation. That's why don't make any change in the denominator. Now one b and this b will get cancelled, d and d will get cancelled, so I am left with k square. This, see, this bracket is there, that means the power of this b also it is square and the power of this k is also square. So separately we can write the powers. Same way here also, this bracket means this whole square is with d also and it is with k also. So d square k square we can write upon b square plus d square as it is. Now here again if we see that this k square, it is there in both. So k square again we can take it out, k square 1 it's already there, into k square we can take out because it's present in both the terms. So if we write it outside, inside I am left with b square plus d square. B square plus d square I already have in denominator. So this b square plus d square and b square plus d square in the numerator both will get cancelled as the same terms. Now k square into k square, into means, see, we have done in exponents also, if bases are same and if they are getting multiplied, so we can add the powers. 2 plus 2. So 2 plus 2 is 4. So k to the power 4 we got on left hand side. Now let's solve the right hand side and see whether we are getting same thing or not. So same things we will use, value of a and b, same way we have to substitute. So right hand side it's given a plus c whole power 4 upon b plus d whole power 4. So a it is equals to bk plus c is equals to dk. So just substituting the values of a and c. In denominator we don't have to make any change because in numerator we converted the terms in the form of b and d, so that we can cancel the common terms. Now this k we can write it outside because it's present in both. So k is common, so common term I will write it outside. So inside I am left with b plus d, and this 4 power is c with k also because whole bracket is there with this k as it is inside. So if we take out common also, then this 4 power it will be there with k also, b plus d. Now here k and b plus d it's getting multiplied, so this 4 I will just write separately with k also, k to the power 4 and here power 4 is there. So b plus d whole power 4. In denominator also b plus d whole power 4. So this and this will get cancelled. So our right hand side is also equals to k to the power 4. So which is equal to left hand side, we can say left hand side is equals to right hand side, hence proved. In 8th question it's given what least number must be subtracted from each of the numbers 7, 17 and 47 so that the remainders are in continued proportion. See, this question is exactly similar to 6th one. Here it's subtracted now, but in that question it was which numbers must be added. So that number we can assume as x. Let x be subtracted from 7, 17 and 47. So that the remainder means after subtracting x from this number, whatever number we get, that number it will be in continued proportion. See, continued proportion we have formula that b square is equals to ac. We will use that formula and find the value of x. This 7 we can write as 7 minus x, 17 we can write as 17 minus x, and 47 we can write as 47 minus x. So this is A, this is B, this is C. See, if we are subtracting x from these three numbers, the remainders, that after subtracting x whatever we get, those three numbers, it will be in continued proportion. That means B square is equals to AC. B is 17, B is mean proportional, so B, I will just substitute the value in this formula and solve it. So 17 minus x whole square, it equals to A is 7 minus x into C is 47 minus x. So here 17 minus x whole square. So we will use the identity of A minus B whole square, which is A square plus B square minus 2 into A into B. So this identity we will use. So A is 17, so 17 square plus B square, B is x, plus B square minus 2 into A into B. It's equals to, these two brackets are together, so that means first term of first bracket I will write first the entire second bracket, then I will write then second term along with the sign. See, if you can write these terms directly before writing this step, you can do that also, but this way we will not make any mistake if we do this way. So minus x into 47 minus x. 17 square means 17 into 17 we can multiply also. So 7 into 7 49. So let's multiply and see, it is 289 plus x square as it is minus 2 into 17, it is 34 into x will be 34x. 7 into 47 again we can multiply, 47 into 7, 7 into 7 49, 28, 29, 30, 31, 32, 329. Minus 7 into x is 7x, minus 47 into x is 47x, minus 47x, minus plus x square. Moreover, whenever minus sign is outside the bracket, you have to change the inner signs. So plus 47 will be changed to minus 47, minus x will be changed to plus x square. So this way also you can remember minus sign outside, so inside signs you have to change. Now let's solve all the like terms first. So 289 plus x square minus 34x, it is equals to 329 minus 329 minus 7x and 47x. These two are like terms. So that's why we can add or subtract accordingly. Minus 7x minus 47, minus plus, but with the minus sign. So 7 plus 47, it's 54. X as it is I have to write, but minus, because it's with greater number also minus sign is there, you can remember that way also, and minus is plus with a minus sign. So minus 54x plus x square as it is we will write. Now we will shift these terms also to this side. So 289 as it is plus x square as it is minus 34x as it is, this it will be minus 329. See, plus 329, when we shift to this side it will be changed to minus 329. Minus 54, when I shift to this side it will change to plus 54, and this plus x square, on changing the side it will be changed to minus x square. So equals to 0. Don't forget to write, because there is a sign of equality and these terms we are shifting on this side. So this sign is still there, but on other side now nothing is there. If nothing is there, we have to write 0. Now again we will see like terms and we will solve accordingly. So this 289 and 329, these two are like terms, so we can solve. Plus 289 minus 329, plus minus minus what with the sign which is with the greater number. So 329 minus 289, we can solve it. So it is 40 but minus 40, because 329 is a greater number, with greater number minus sign is there, so minus 40. Now x square and x square, but both x square and x square is same with opposite sign, so x square minus x square is 0, so directly you can cancel. Now we have minus 34x plus 54x. Again these two are like terms, we can solve. Plus minus minus, but the sign which is with the greater number. So 34 minus 54 is, or 54 minus 34 is 20, so 20x we can write, but with 54 which is greater number, plus sign is there, so plus 20 it will be. Now we have to find, see, value of x we have to find, because x we are subtracting from each of the terms. So x term we will write on this side, 20x is equals to minus 40, because step by step all the other terms we have to shift to other side. Minus 40 we will shift first, so it will be changed to plus 40, 0 plus 40, so 0 plus 40 directly I will write as 40. Now x, alone x we have to find, so this is 20x, so 20 also we will shift to other side. So 20 it is getting multiplied this side, multiplied by x. When we shift it to other side it will get divided. So 0 and 0 cancel, 2 into 1 and 2 into 2. So x is equals to 2. We can subtract 2 from each of these numbers, like 7 minus x. 7 minus x means 7 minus 2, because x is equals to 2. 7 minus 2 is 9. And 17 minus 2, 17 minus 2 is 15. 7 minus 2 is 5. 17 minus 2 is 15. 47 minus 2, because x is equals to 2, so that is why value of x I am substituting. So it is 45. Now these are the remainders, like after subtracting x, which is 2, after subtracting 2 from each of these numbers, so I am getting 5, 15 and 45. So these three will be in continued proportion, so that least number is x, which we are subtracting from these numbers to make them a continued proportion.